Hello friends, welcome to the session continuation of three-phase bridge inverter with respect to 180-degree mode that I discussed how to draw this phase and line voltage waveforms. Okay, what exactly 180-degree mode that I discussed. Okay, now based on this 180-degree mode, now based on these wave shapes, all these, we want to list out some points that you concentrate. I told that a three-phase bridge inverter is also called six-step inverter because in one cycle, how many steps we are getting? 1, 2, 3, 4, 5, 6. 6 steps we are getting now. That's why it is also called six-step inverter. Okay. Now, we want to list out some points with respect to 180-degree mode. Tell me. Every point is important. In 180-degree mode, each switch conduction angle. Each switch conduction angle. Parallelly, all of you write down. Each switch conduction angle. How much you tell me? How much? 180 degrees. That's why it is called 180-degree mode. Each switch conduction angle is 180 degrees. Next. At a time, how many switches are conducting? At a time, 3 switches are conducting. That is, 3 devices are conducting. At a time. 3 switches are conducting. 3 switches are conducting. At a time, 3 switches are conducting. Yes. Tell. Each switch is triggered at angle of 60 degrees. Each switch is triggered. Each switch is triggered at angle of 60 degrees. Triggered at angle of 60 degrees. Yes. Tell. What is the shape of phase voltage? The shape of the phase voltage is stepped waveform. It is stepped waveform. The shape is, I'm talking about shape. The 3-stepped waveform. For a half cycle, we are getting 3 steps. See, this is also called stepped, but the number of steps will be different. This is also called stepped waveform. Okay, but the number of steps is different. Understood? It is a AC waveform, but the stepped wave. But here, how many shape of the steps here? 3-stepped. That's why the name is given as 3-stepped waveform or 6 steps square waveform. Yes, sir. The name is also called 6-step square waveform. But it is not constant square waveform, but it is a 6-step square waveform. That's why each switch is triggered at angle of 60 degrees. Phase voltage is 3-stepped waveform. 3-stepped waveform. The shape I am telling are 6-step square waveform. Square waveform. Now tell me. What is the maximum amplitude of phase voltage? The maximum amplitude of phase voltage is 2 by 3 Vs. Maximum amplitude of phase voltage. Maximum amplitude of phase voltage. Yes. Concentrate. All of you. Parallel note down. Maximum amplitude of phase voltage. How much? 2 by 3 Vs. Yes. Tell. What is the shape of the line voltage? What the shape of this one? Quasi-square waveform. What the maximum amplitude of line voltage? Yes. Maximum shape of the phase, that is line voltage is quasi-square waveform. Quasi-square waveform. Line voltage is quasi-square waveform. Okay. Then maximum amplitude of line voltage. Maximum amplitude of line voltage. Maximum amplitude of line voltage. How much? Vs. Maximum amplitude of line voltage is Vs. Yes. Then one more point you remember here. In this point is applicable either 180-degree mode or 120-degree mode. Phase difference between two sequential SCRs. Either top or bottom. Is how many degrees? 120 degrees. Phase difference between two sequential SCRs, either top or bottom, is 120 degrees. Can you accept this? 180-degree mode means what the sequence we are allowing? 1, 2, 3, 2, 3, 4, 3, 4, 5, 4, 5, 6, 5, 6, 1, 6, 1, 2. Like that we are allowing. 6, 1, 2. Okay. Now I am telling phase difference between two sequential SCRs, either top or bottom, is 120 degrees. Top means 1, 3, 5. Bottom means negative group 4, 6, 2. Angle between 1 and 3, 3 and 5, and 5 and 1 is 120 degrees. Accept this. Listen please. You take 1 and 3, or you take first, I will start with 3 and 5. Here 3 is triggered. 60 plus 60. After 120 degrees, 5 is triggered. That's why angle between these two is 120 degrees. Angle between these two is also 1. 3 and 5 is 120 degrees. Next. Here 5 is triggered. 60 plus 60. After 120 degrees, 1 is triggered. Then angle between 5 and 1 is 120 degrees. Here 1 is triggered. 60 plus 60. After 120 degrees, 3 is triggered. Angle between 1 and 3 is also 120 degrees. Phase difference between two sequential SCRs, either top or bottom, is 120 degrees. Like this only you can maintain to get the balanced three-phase voltages at output side. Understood? Now what about 462? Here 4 is triggered. 60 plus 60. After 120 degrees, 6 is triggered. Angle between 4 and 6 is 120 degrees. If you don't maintain like this, you don't get balanced voltages. Then 120 degree phase difference we can maintain. Then 6 and 2, you tell me. Here 6 is triggered. 60 plus 60. After 120 degrees, 2 is triggered. How much? 120. Again, angle between 2 and 4. 2 and 4 is also 120 degrees. Here 2 is triggered. 60 plus 60. After 120 degrees, 4 is triggered. That's why the phase difference between two sequential SCRs, either top or bottom, is 120 degrees. Now let's see. What is the analysis of this line and phase voltage? That I want to explain. Okay. These are the theory points you concentrate. Okay. Clear? We'll see some analysis on the line and phase voltages. Yes. But you concentrate. Analysis of line and phase voltages. Analysis of line and phase voltages. This I am explaining in 180-degree mode only. Yes. Tell. First, concentrate. I am explaining on star connected. You also write the formulas for delta connected. Just phase and line voltage relation will be changes. Tell me. By seeing the waveforms, for which waveform easy to calculate RMS value. It is a stepped waveform, it is a quasi-square waveform, it is a constant waveform. Here amplitude is changing. That's why better to calculate line voltage. It is easy to calculate. Once you know the line voltage RMS value, calculating the phase voltage is very easy based on star connected relations. In a star connection, what is the relation between line and phase voltage that you know? You can apply that one. Deriving that formulas are very easy. Okay. This is the approach you follow. This you go based on this approach only. I am deriving this one. Okay. Here first I am calculating line voltage RMS. Then I will calculate the directly phase voltage RMS also you can calculate, but it is a somewhat lengthy procedure. Because it is stepped waveform. That's why I am doing the line voltage first because it's a constant. First, RMS value of line voltage. RMS value of line voltage. Parallelly, all of note down. All of you note down. RMS value of line voltage. RMS value of line voltage. VL equal to. What the amplitude of line voltage? Vs. The amplitude of line voltage is Vs. Vs into square root of. Amplitude of line voltage is Vs. Vs into square root of. This total is one cycle, 360 degrees. This total is one cycle, 360 degrees. In one cycle, how much angle? Line voltage is exist. 60 plus 60, 120. 60 plus 60, 120. Total, 240 degrees. This is a quasi-square waveform, na? 240 degrees it is exist. Then 240 by 360. Then how much you get? Vs into square root of 2 by 3. That equal to 0.8165 Vs. This is the RMS value of line voltage. In competitive exam, direct formula also asking. Concentrate. You simplify this root 2 by 3, then we can get 0.8165. That is RMS value of line voltage equal to 0.8165 Vs. Once you know the RMS value of line voltage, calculating RMS value of phase voltage is easy. RMS value of phase voltage. Okay. RMS value of phase voltage. Okay. V phase equal to. V phase equal to. Okay. I am assuming that star connected. In a star connection, V phase equal to VL by root 3. But it is a delta connected, V phase equal to VL. That relation is only changing. But I am writing only for star connection. VL by root 3. Then what you get? Vs into root 2 by 3 by root 3. Then how much you get? V phase equal to Vs into root 2 by 3. Then how much you get? 0.4714 Vs. This is simplified. Yes. Next. RMS value of load current is equal to RMS value of phase current. RMS value of load current is equal to, both are same. RMS value of phase current. RMS value of phase current. Phase current. RMS value of phase current. Therefore, I phase equal to V phase by, you take for phase resistance. Okay, I phase equal to V phase by R per phase. Okay, R per phase. I phase equal to V phase by R per phase. Sorry, this you write like this. V phase by R per phase. Once you know the phase current, average value of each switch current or each thyristor current. Here the switch may be thyristor also we can use based on application. Okay, average value of switch current, average value of switch current or average value of switch current or thyristor current. How much you get? Switch in the sense ISW average or IT average. Each switch or thyristor also supplying phase current only. Then I phase into how much angle it is conducting? 180 degrees. That is 180 by 360. That you can get I phase by 2. Average value of each switch current or thyristor current is I phase by 2. Because how to define? Average value means on time by total time period. How much angle each thyristor is conducting? 180 degrees in one cycle. 180 by 360. That is equal to I phase by 2. Next. RMS switch current or thyristor current. RMS switch current or thyristor current. Then how we can write? ISWR equal to or ITR equal to, then I phase into RMS value means you take square root 180 by 360. That is I phase by root 2. Okay. Then three phase load power. Then how to calculate three phase load power? Three phase load power equal to 3 into I phase square into 3 into I phase square into R per phase. That equal to 3 into V phase into I phase into cos pi also you take. If it is a resistive load, take the unity power factor. Yes. This is the analysis of line and phase voltages in 180 degree mode. That you can. Every formula is important in any competitive point of view. Quick, note down. Yes, over. This is generalized analysis of line voltage and phase voltages. But still I want to extend this concept, important for competitive. Tell me. Whatever the phase voltage and line voltages we are getting, it is a AC waveform. No doubt at all. We are converting DC to three phase AC. This also AC, this is also AC. You take 180 degrees, positive, negative, 180 degrees, positive, negative, 180 degrees, positive, negative, negative, positive, 180 degrees, positive, negative. These are AC waveforms. That's why we calculate average value of any waveform. It is 0 because it is a AC waveform. But even though it is a AC waveform, is it a pure sinusoidal? No, it is not a pure sinusoidal. It is a non-sinusoidal. Now, any non-sinusoidal waveforms are analyzed by applying Fourier series. Now I want to explain what is the Fourier analysis of phase voltage and what is the Fourier analysis of line voltage waveforms. Here, I don't want to give the derivation for all these phase and line voltage, all these waveforms. Okay, just I am summarizing some formula. That formula you concentrate. After summary, I will write some formulas. Once I am writing equation, from that I will write some formulas. That is important for competitive point of view. No need to apply again, calculating A naught, AN, BN, substituting, deriving all this. No need of this one. Understood? Now see, what is the Fourier analysis of 180 degree mode? Then for line voltage and phase voltage. Understood? Okay. Why we are going for Fourier analysis? Because it is not a pure sinusoidal. Any non-sinusoidal waveforms are analyzed by using Fourier series. Yes, concentrate. Fourier analysis of 180-degree mode. Fourier analysis of 180-degree mode. First, you concentrate on phase voltages. Phase voltages. Then if you apply Fourier analysis for this waveform, phase voltage, then instantaneous value of nth harmonic phase voltage, A phase, then B phase, C phase you want to write. See, we can also write by your own except one formula. In 120-degree mode, line voltage formula enough. So except that line voltage formula in 120-degree mode, you can write the formula by your own. I am talking about amplitude. Writing the functions are very easy. Okay, that depends on Fourier series formulas only. I am talking about how to write the amplitude. Okay, it is not a concept. I am telling that how to approach that one without doing analysis also. Every time doing analysis, deriving and writing that formula, computative point of view is lengthy procedure. That is not way. That is not the approach. Okay. Now, I want to write what is the nth harmonic phase voltage. Instantaneous value of nth harmonic phase voltage. Yes. It is a stepped waveform. Because of stepped waveform, it consists of 6k plus or minus 1 harmonics up to infinity, where k equal to 0, 1, 2 and so on. 6k plus or minus 1 harmonic means it does not consist of triple N harmonics. Because of AC waveform, because of symmetrical waveform, inherently even harmonics are absent. Along with even harmonics, triple N harmonics also absent. No doubt at all. Inherently, because of symmetrical nature, it may be line voltage or it may be phase voltage, even harmonics are absent. But in the phase voltages, along with even harmonics, triple N harmonics also absent. 6k plus or minus 1 up to infinity. Tell me, the phase voltage na? I told 3-phase bridge inverter means each phase is nothing but a combination of 3 half bridge inverter na? 3 half bridge inverter means each phase is nothing but a 1 half bridge inverter. Here I am talking about one phase. One phase is nothing but a half bridge inverter. That you know already formula for half bridge inverter. 2 Vs by n pi. See, that like that we are writing by your own. As each phase is nothing but a 1 half bridge. 1 half bridge is nothing but you already derived the formula in single phase half bridge, that is 2 Vs by n pi. Then function is sin n omega t. Sin n omega t. This is that. This I am talking about this function, this value. You can write this value by your own, but this sin n omega t is the function. As 3-phase voltage, 3-phase bridge inverter is combination of 3 half bridge inverter. As one phase is nothing but a 1 half bridge. 1 half bridge is nothing but half bridge formula 2 Vs by n pi. That is sin n omega t. Like that you remember. For remembering purpose that I am telling. Then remaining you write VBN. Summation 6k plus or minus 1 up to infinity. 2 Vs by n pi sin n omega t minus 120. Yes. VCN equal to summation 6k plus or minus 1 up to infinity 2 Vs by n pi sin n omega t minus 240. Just to remember only one phase one. No need to remember this one. Once problems or formulas are asking means you can concentrate on amplitude only. No need of function. Understood? Even in GATE exam also the questions are framed. Direct formulas also framing based on this concept. Understood? Okay. That's why no need to concentrate on the function. Once we are writing descriptive point of means concentrating. If you want to write in IS descriptive point means concentrating on the function also. Each phase is displaced by 120 degrees. Omega t minus 120 minus 240. Okay. Now this is the Fourier analysis. If you apply the Fourier analysis for this phase voltage, then we can get this one. Now from this, I want to list out some points here. One or two formulas. You tell me. We are not by hearting this one. Among all these, you remember only one. From that, you are writing this one. Tell me, what is the maximum value of nth harmonic phase voltage? Maximum value of maximum value of nth harmonic phase voltage. Nth harmonic phase voltage. Maximum value of nth harmonic phase voltage. That is VANM. How much? Amplitude indicates maximum value 2 Vs by n. Maximum value of fundamental voltage. Maximum value of fundamental. You tell me. What is the maximum value of fundamental? Any formula, once you can remember this one. No need to remember everyone. No need to remember every phase voltage. Then you take only one phase voltage. Then maximum value of fundamental phase voltage. Then you take VA 1M. N equal to 1. 2 Vs by pi. And this formula is asked in GATE exam. 2 Vs. In 2017 GATE, this is asked. Direct formula is asked. 2 Vs by pi. Next. RMS value of nth harmonic phase voltage. RMS value of nth harmonic phase voltage. Nth harmonic phase voltage. You tell me how much? How to get RMS value? VANR equal to maximum value by root 2. That is root 2 Vs by pi. Root 2 Vs by pi. That is root 2 Vs by n pi. Then what is the RMS value of fundamental? You tell me. RMS value of fundamental voltage. You write any formula. RMS value of fundamental voltage. Fundamental voltage. How much? Root 2 Vs by pi. You take n equal to 1. Here n equal to 1. This is maximum value of nth harmonic output. What is the maximum value of fundamental voltage? What is the RMS value of nth harmonic voltage? What is the RMS value of fundamental voltage? It consists of 6k plus or minus 1 harmonics means if you substitute k equal to 0, fundamental, k equal to 1, we can get either 5 or 7 harmonic. If you substitute k equal to, we can get 11th or 13th harmonic. We don't have any third harmonic, we don't have any 9th harmonic, we don't have any 15th order harmonic. That means in phase voltages, in 180 degree mode, in phase voltages, all triple N harmonics are absent. All triple N. Inherently, because of symmetrical, already even harmonics are absent. Along with all triple N harmonics are absent. All triple N harmonics are absent. That you write. Okay. All triple N harmonics are absent. Triple N harmonics. All triple N harmonics are absent. In the case of 180 degree mode, in phase voltages. These are phase voltages. Then similarly, we can apply Fourier analysis for line voltage also. Fourier analysis for line voltage also. That you will see. Then line voltages. Then write one line voltage is VABN equal to instantaneous value of line voltage. How to write the amplitude in line voltage means simple. One line is nothing but a combination of two phases. Combination of two phases is nothing but a combination of two half bridge inverter. Okay. See, this point I am telling for remembering purpose. Understood? Combination of two half bridge inverter. Combination of two half bridge inverter is nothing but one full bridge inverter. That you write. Summation n equal to 135 up to infinity. Two half bridge inverter, one full bridge, 4 Vs by n pi. But point to remember, this 4 Vs by n pi formula is derived for square waveform. In single phase full bridge inverter, 4 Vs by n pi formula is derived for square waveform. But here, what is the waveform we are getting in 3 phase bridge inverter? Quasi square waveform. Because of quasi, then you write this extra term we can get by applying Fourier analysis. Cos of n pi by 6 sin n omega t plus 30. This we can get. By applying Fourier analysis for line voltage, this we can get the function also. Sin n omega t plus 30. Understood? By considering a phase difference between phase and line voltage, that I am writing. Okay. Now, VABN. Similarly, VBCN. Summation n equal to 135 up to infinity. Just you remember up to this amplitude, no need to remember the function all this. 4 Vs pi n pi cos. This is same. For any line, this will be same. This only function is changing. Sin of n omega t minus 90. VCAN. Summation n equal to 135 up to infinity 4 Vs pi n pi cos. This cos of n pi by 6 we are getting because of quasi nature. Sin n omega t minus 210. This we can get. And these are the instantaneous value of line voltages. Instantaneous value of line voltages in 180-degree mode. Understood? Okay. Now from this, we can write any formula. For example, maximum value of nth harmonic line voltage. Maximum value of nth harmonic line voltage. You tell me. Nth harmonic line voltage. Nth harmonic line voltage. How much? VABNM. How much you tell me? 4 Vs by n pi cos n pi by 6. Without function, remaining term is taken as a maximum value. Next. RMS value of nth harmonic line voltage. RMS value of nth harmonic line voltage. Nth harmonic line voltage. RMS value of nth harmonic line voltage. How much? VABNR. Then by root 2. Root 2 by n pi into Vs cos n pi by 6. Yes. What is the RMS value of fundamental line voltage? RMS value of fundamental line voltage. RMS value of fundamental line voltage. Line voltage. RMS value of fundamental. You substitute n equal to 1, then what you get? 2 root 2 by pi into cos 30. Cos 30 is root 3 by 2. 2 cancel. Then what you can get? RMS value of fundamental line voltage. VAB1R equal to root 6 by pi Vs. This is Vs, no? Vs. root 6 by pi Vs. Direct formulas also important. Just you remember one line voltage, from that you answer any question. Understood? Okay. But one observation here, in 180-degree mode, either phase or line voltages. In line voltages, triplet harmonics are absent. Sorry, in phase voltages, triplet harmonics are absent. That you see in 6k plus r minus 1. Then what about in line voltages? See, what is the term? You take quasi term. You take cos of n pi by 6 term. Cos of n pi by 6. You substitute n equal to 3. You substitute n equal to 9. You substitute n equal to 15 and so on. For all these, cos of n pi by 6 equal to 0. Because of quasi nature. Cos of n pi by 6 equal to 0 means because of quasi nature. Then this for n equal 3, this total value is 0. For n equal 9, this total value is 0. For n equal 15, this total value is 0. That's why we don't have any voltage due to third harmonic, ninth order harmonic, 15th order harmonic means. Therefore, all triple N harmonics are absent. 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 That you write. Okay. Because of quasi nature, if you substitute n equal 3, n equal 9, n equal 15 here, in the case of 180-degree mode of line voltages, all triple N harmonics are absent. Yeah, this is about Fourier analysis of line and phase voltages in the case of 180-degree mode of operation. Okay, that you concentrate. Okay, no doubt. Yes, 1 minute please. Listen. Here I am writing as a note. In 180-degree mode, in both line and phase voltages, triple N harmonics are absent, but only pole voltage consists of triple N harmonics. That point is important. Here I am not discussing pole voltage, Fourier analysis, all this. That is not required. Okay. In 180-degree mode, only in 180-degree mode, both phase and line voltages, phase and line voltages does not consist of triple N harmonics. Does not consist of triple N harmonics. Triple N harmonics. But only pole voltages consist of, how to measure the pole voltage at the starting I given. Pole voltage consists of triple N harmonics. Only pole voltage consists of triple N harmonics. Okay. That's one point you remember. Okay. But inherently, even harmonics are absent. Another point. In the case of 180-degree mode, we know that what is the sequence of conduction of devices? That is 1, 2, 3, 2, 3, 4, 3, 4, 5, 4, 5, 6, 5, 6, 1, 6, 1, 2, like this it is conducted. Three-phase bridge inverter means this is a circuit, you know. I am not drawing clearly, no need of that. Just I want to explain one point, that's why I am giving like this. Okay, this is load. S1, S3, S4, sorry, S1, S3, S5, S4, S6, S2. See, in 180-degree mode, Here 1 is outgoing device, outgoing switch. 4 is incoming switch. Yes. This 1 and 4 is on the same leg now. That's why in the case of 180-degree mode, the 2 switches in one leg, if 1 is turned off, 4 going to be on. That's why in 180-degree mode, there is no phase difference. 2 switches in one leg. Here 1 is turned off means 4 is on. If any commutation failure of 1, still 1 is on condition. But you already trigger 4 also. Then 1 is on, 4 is on. Then current will not enter into the load. Then it will be short circuited. Understood? That's why in 180-degree mode, there is no phase difference. 2 switches in one leg. But that is not the problem in 120-degree mode. That I will explain. That's why in 180-degree mode, if the 2 switches in one leg, there is no phase difference. Hence, there is a possibility of shoot-through fault. Shoot-through fault. That I told now. If any short circuit fault is occurred through the source, that is called shoot-through fault. That's why. Therefore, in 180-degree mode, there is no phase difference. 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 2 switches in one leg. 2 switches in one leg. In one leg. Hence, there is a possibility of shoot-through fault. There is a possibility of shoot-through fault. Possibility of shoot-through fault. Shoot-through fault in the sense, short circuit fault through the source. There is a possibility of shoot-through fault. The another point you remember, in 180-degree mode, at a time, 3 switches are conducting. But in 120-degree mode, that is only 2 switches. That you will see later on. That's why, in 180-degree mode, switch utilization factor is high. Switch utilization factor is high. Switch utilization factor is high. Because at a time, 3 switches are conducting. Okay, these points, some points you remember, special points with respect to 180-degree. Remain some other 1 or 2 points I will discuss after completing 120-degree mode also. Mainly concentrate on this one. For example, just an example I am giving. If it is asked like this. A 3-phase bridge inverter, a 3-phase bridge inverter, a 3-phase bridge inverter operated in 180-degree mode. Operated in 180-degree mode. 180-degree mode. Okay, first one. Maximum value of fundamental phase voltage. Fundamental phase voltage. If the question is asked like this, fundamental phase voltage is dash. But the answer this one that you know. They are already derived. 2 Vs by pi. RMS value of fundamental phase voltage. RMS value of fundamental phase voltage. Fundamental phase voltage. How much you tell me? Is dash. But the answer for this one that also I derived. Root 2 by pi. Root 2 by pi into Vs. That you. Next. Maximum value of fundamental line voltage. Fundamental line voltage. How much? Fundamental line voltage. How much? What is the answer? This one you tell me. What is the maximum value of fundamental line voltage? S. What is the fundamental RMS voltage? Fundamental RMS voltage root 6 by Vs. If you want maximum value means root 2 times of RMS na, or otherwise 4 Vs by pi cos pi by 6. 4 Vs by n pi cos of n pi by 6 na, n equal to 1. 4 Vs by pi cos pi by 6. Cos 30 root 3 by 2. Then what you can get? Root 3 by 2 means then this is 4 Vs by pi into root 3 by 2. Then how to write 2 root 3 by pi Vs. Then if it is asked RMS value of fundamental line voltage. RMS value of fundamental line voltage. Fundamental line voltage. How much? That I calculated. Root 6 by pi into Vs. Root 6 by pi into Vs. Okay. Like this, any question we can answer. Any question we can answer. If it is asked, RMS value of third harmonic phase voltage. RMS value of third harmonic line voltage. If it is asked, third harmonic line voltage. We know that in 180-degree mode, triplet harmonics are absent. Then what is the third harmonic line voltage? 0. All triplet harmonics are absent. All triplet harmonics are absent. That you know. Understood? Like this, you answer any question. If it is asked, fifth order harmonic line voltage. Fifth order harmonic line voltage means 4 Vs by 5 pi cos of 5 pi by 6. N equal to 5 you can replace. Like this you can answer any question. Maximum based on this Fourier analysis in 180-degree mode or 120-degree mode, they are asking the direct formulas also. You ready to answer? Okay, with this 180-degree mode is completed. In the next session, we will continue with 120-degree mode. With that, the concept with respect to Fourier, the concept with respect to three-phase bridge inverter will be completed. Understood? Okay, clear? No doubt.